Hi, welcome to this video. This is really a modern look for 2023, looking at SPE to API, screen printed electrodes to application program interface. And it's really, as I say, a modern look at actually how to take simply an idea, an electrochemical assay idea on a screen printed electrode, and how to turn that into a minimally viable product with an API. And an API is really your way of scaling and monetizing the ideas. So let me go forward very quickly and say that what we've done at ZP is really make a technology stack of really excellent electrodes, really excellent parallel potentiostats for the lab, really excellent sense it all platform, which is what we call an OEM solution, which means that other people can use it in their products, and then actually have a Julie database which has API. So it actually has all the elements that you need to go, or at least this technology stack has all the elements you need to go from results in the lab to hardware in the hands of either testers or actual customers. So let me talk about this self-service productization, starting with screen printed electrodes. So electrochemical assays really are changing the world. They've been in development and maturing for at least 40 years. When we look at the electrochemical assay behind glucose sensors, so glucose sensors for type 2 and type 1 diabetics, they've really paved the way. So, electrochemical assays find themselves in environmental monitoring, healthcare applications, agriculture, food and beverage. And when you say you name it, there's something called Industry 4.0, where industry is recognizing that actually sensing is really going to be part of the next industrial revolution. So SPE to MVP to API. Screen printed electrodes to minimally viable products to application program interface. And this is really what I'm going to discuss. The revolution that I really want to touch upon is this sense that actually, if you have an idea at the moment, if you're in academia, for example, you can come up with a new electrochemical assay, and you might, and I would actually recommend that you do it on a screen printed electrode. I would recommend that even if you think you have to be on a gold electrode or platinum electrode, I'd actually say have a serious reconsideration of this, because platinum and gold are spiraling in cost. They're never going to come down, but there's actually a large sources of carbon and graphite around the world, and actually that means that we can always kind of keep the price of carbon electrodes down. So what I'm going to talk about here is how to step over this line from ideas and things that you may otherwise do in a lab and may otherwise just publish. I may even put into patents, but actually talk about how to turn them actually into products. So what we have running here is the Sense It All, and I'll try to remember to put a link underneath this video. But what we have here is the Sense It All platform, and this is really an OEM solution. So OEM stands for Original Equipment Manufacturer, and so essentially if ZP was manufacturing it, you would be using it in your product, and it would allow you to have a very kind of tangible, I want to say nice looking piece of hardware that you're either giving to testers or you're actually using as your product. Now, what's happening at the moment, there are companies out there that kind of make their potentiostats available to you as, let's say, equipment, but they look like potentiostats. Whereas this actually, I would say that the sort of design and engineering that's gone into this is much, much, much more of a kind of consumer experience. And I'd even say with the sort of, with the coloring and the texturing on this, and the ease of sort of use of this, this is much akin to a sort of iPhone type application, and a look and feel and quality. So the rest of this video is really about how to go from these ideas, and then as long as you tick the box that it's an electrochemical assay, be it potentiometric, amperometric, voltammetric, or impedance spectroscopy, and that you use screen printed electrodes, which really have proven themselves to be great in applications like glucose sensors. As long as you tick those two boxes, then at ZP we do have a platform, a whole stack of technologies rather, to actually get you onto this Sense It All platform, and really on your way to either just an elegant solution to use with academic collaborators, or even a product to use with customers. So just a side note on screen printed electrodes. And I put here SPCE, so I am talking now specifically about screen printed carbon electrodes. I already just said it, but please, 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 if you can avoid gold and platinum, and actually you can avoid gold and platinum if you're doing self-assemble monolayers, where often gold electrodes are used. There are chemistries that will allow you to couple to carbon surfaces. I'm just thinking about pyrene NHS, for example. There are always chemistries where you can, instead of using gold, you can use carbon/graphite. If you're using platinum, many often people have like peroxide type assays, or they may be using oxidase enzymes, and hydroperoxide is the end material of that. You can avoid platinum. You can use mediated. You can put a mediator down on the carbon, and the mediator will then allow the hydroperoxide to interact with the carbon electrode. So there are always ways. If you're not sure of this, then it's probably worth contacting essentially ZP. What's the big problem with screen printed electrodes and screen printed carbon electrodes? The big problem is, and this doesn't apply to ZP screen printed electrodes, is reproducibility. And I should really sort of change this and say irreproducibility. And what I mean by that is, you will take two electrodes that otherwise look the same, test them with the same solution, and get vastly different answers. That's a real problem. Everyone knows it, but we're not changing the workflow. We just keep on reordering these things, or just complain about it. But that reproducibility is a real problem. I am going to say that ZP has overcome this reproducibility, and I'll give you some evidence of that on some other slides shortly. Irreproducibility in the manufacturing of these screen printed electrodes, and even if you make them in-house, I think there's often even a worse situation, that you don't get reproducibility. It then leads you to terrible repeatability in the lab. Or terrible is overstating it. But sometimes you'll have to do like 5 tests in order to get 3 tests that kind of make sense, because you think that 2 of the tests are outliers, and those 2 outliers you have a strong suspicion are actually down to the screen printed carbon electrodes. But of course, it's always a suspicion. At ZP, we don't have this problem. Why? Because we've got reproducible electrodes, and I would strongly drive you towards screen printed carbon electrodes. So we have good repeatability on our products and in our testing. I also want to say cost in the research. This reproducibility does cost you in your research. Now, those costs might be quite soft because actually, it's students' time. But you are wasting materials and you are wasting time if you have to repeat things because of actually the underlying electrodes are not reproducible. This is even worse in the situation of development, where development often takes place in commercial organizations, where salaries are higher and you have to get to market. You have milestones, and I've seen this a lot, where basically people are held up because the screen printed electrodes are all over the place. So cost in development is a problem. Now, what happens then is that because people are getting these irreproducible electrodes, they then end up introducing calibration in the field. If you've got a product that's on its way to market and you've got calibration in the field, where the end user or some complicated cartridge has a calibration routine associated with it, that's a problem. You shouldn't be there, and it's probably there because the underlying screen printed electrodes are actually not reproducible enough. If you recognize any of this, I strongly suggest coming over to ZP's screen printed carbon electrodes, especially our hypervalued carbon electrodes. Now, factory reproducibility. So at ZP, we're really careful on the reproducibility of our electrodes. Why? Because we use them all the time ourselves in our own products. So we would take, like, say, sheets, and here I'm talking about quite a short run of something like 26 sheets. So that's about 7,800 electrodes for us. And we'll take sheets through the run, and we'll actually check them for variation, the coefficient of variation. And make sure that within a sheet, we get something like a 4, or let's say a 6% variation. So we're keeping an eye on making sure these electrodes are reproducible enough that we can benefit from them. And by the way, we also then make them available to the academic community and also the development community. And then we just check the average standard deviation, the average coefficient of variation. And we also then check the sheets relative to one another. So we sort of do an intra check and an inter check, and just make sure that the entire batch is actually reproducible. So this whole video is really about commercializing electrochemical assays which are using screen printed electrodes, and I'm talking about a technology stack, and the beginning of the bottom of the technology stack is actually getting reproducible electrodes. By the way, our electrodes do actually correlate with theory, but I actually think this is I think this distracts people. We do get people who come quite a bit and say, oh, well, do you match with theory? Yeah, sure, we can match with theory. But by the way, if you're really trying to make a commercial product, whether you have a peak to peak separation when testing with something like 5 millimolar ferricyanide, whether you have a peak to peak separation of 59 millivolts, it's interesting and it tells you something about the electrodes, but it's not the thing that's actually stopping you get to market. So here when we do a nice sort of slow scan rate, we get something like 67.5 millivolts per second. But what we're really focused on at ZP is actually the reproducibility of these electrodes. So we have something called Julie. It's an online database. We test the electrodes. We test something like their peak height, and then we can look at their mean, the standard deviation, the relative standard deviation, which some people call coefficient of variation, the median, the min, the max. So we've essentially done these what we call KPIs, key performance indicators, and basically checked the batch and kind of given it an approval failure. Why do we do this? Because we use these electrodes, and actually this also forms the basis of a technology stack that we think you can actually use in your product or going to market. What we're actually doing at ZP is eliminating something that we call the chasm. So the chasm is, there's a chasm that's kind of recognized in academia between what academia does and what commercialization. So this is Professor Richard Compton. We have licensed technology from his group, and that Richard would be on one side, and then we would have something like a product on the other side. And so this is one of the products that we have licensed from Richard. We use it for testing the hotness of chili. But this chasm exists, and what ZP we've been doing is actually filling in the chasm with a series of technologies. First of all, repeatable electrodes. If you've got repeatable electrodes, you've got the foundations of a commercially viable assay. The next thing that we're filling in is with our EMA potentiostat, because our EMA potentiostat allows us to actually do a lot of parallel testing, which really speeds up the effort, put statistically significant numbers behind us, and importantly, the method files are then compatible with something called Julie, and Julie is compatible with something called Sense It All, and this is how we then go from screen printed electrode through the potentiostat into the cloud and onto a platform called Sense It All, which is actually the OEM solution, and OEM in this context means original equipment manufacturer. So screen printed electrodes, we partly fill in this chasm with that. Potentiostat, these are equipment people would have anyway as part of their research phase, but we've made it so that it actually expands across the gap. The next part then is the actual Sense It All platform, which is really a piece of hardware that you can it can receive the files from Julie, the method files that you'd use in the lab, get translated across to the Sense It All platform, and then the last bit then I should have just kind of gone a bit slow on that was an API. So we've built an API into this. An API is an application program interface. If you're not aware of it, then come to one of our workshops, but we will talk about how to monetize in those workshops your API. You should always have an API strategy these days. This is really the sort of pieces of code that mean that we can pay for things online. You can buy tickets online. Everything is essentially held together these days by API. So the first part of this is screen printed electrodes. We make a really reproducible one. You may be able to use those screen printed electrodes just in your electrochemical assay. It's always good to keep it simple, but you may also have to functionalize them with some nanomaterials and polymers, something that you want to actually do to the electrode, and the electrode itself might be just a current collector. So you can characterize that. You can functionalize that. Now the problem there is that's probably this functionalization that you're just about to do is probably your biggest route of irreproducibility. At ZP we would use robots. If you're not set up for it, then you will have to use a contract manufacturing organization like ZP to actually do that. So the next part of this really is EMA. This is EMA. It's a 6-channel potentiostat. It's particularly set up for really doing electrochemical assay development, and the fact that it's small is nice. The fact that it can then run 6 tests at the same time is really important because you need to get statistical data on this. And then EMA is elegant because you can develop your method on that, and those method files are all the time getting saved into Julie. Julie is a cloud database system, so ZP kind of has this sort of sensor test cloud workflow. So now that you know where your data is, you know where your method files are, And Julie is really the start of a self-service on your way to productization. So what I mean by that is Julie, you develop the method files in the lab. The method files go up to Julie. In Julie, you come up with a signal extraction routine. So what I mean by that is you will have a method file and you'll run that method with different concentrations of the analyte or different properties that you want to measure. And you will devise a signal extraction routine in Julie. And then Julie will come up with or you will come up using Julie a concentration, sorry, not concentration, but a calibration routine or a calibration algorithm. So method file is what you're doing in the lab. Signal extraction is when you're basically doing your data science in the cloud using the tools that we already have, and the calibration algorithm will also come out of the cloud that we also have. What does Julie then allow you to do? It allows you to generate a QR code. And this QR code now is essentially all the kind of work that you've done gets wrapped up in this QR code. And this is the heart of us actually turning what you did in the lab across to the Sense It All platform. And then you're on your way to this minimally viable product or even product. So the QR code works with an app that's called Sense It All. Sense It All, the app, will actually read the QR code, and it will, anything that you've developed gets carried into the QR code and gets put into the app. So that will bring your method file across, and then your method file will then get used in the following workflow. So the sort of following workflow that I'm describing here, or I'll show you here, is you will take something like a sensor, and the engineer is actually holding the sensor in her, just silence that, is holding the sensor in her hand, and I would just slightly pull myself out of the way. So she's holding the sensor in her hand. So this is the sensor. We have hardware, but the hardware actually has got a lot more elegant these days. In fact, there's the hardware now. You can see my hand upon that. Really quite nice. It clicks in, it clicks out. And that's really important because at the moment people are kind of using these kind of instruments where they're kind of slotting this thing into the front. And by the way, that slotting, those connections soon wear out on those slotting ideas. And also it's very easy to get liquid into the connections, so that's an absolute disaster. So this one, you'll just see it clicks around really elegantly. So I was talking earlier on about you developing a method file on the EMMA potentiostat, which is a 6-channel potentiostat, very efficient because it's got the 6 channels. The method files go up into the cloud. Julie will actually take on your work and turn it into a QR code, and then the app will read that QR code and actually bring all that kind of, let's say, development into an app, so you get a very user experience. So we've got Julie, and what happens is you put the sensor, it's either a bare screen printed electrode from ZP because that's all you needed, or it's a functionalized screen printed electrode from ZP that you functionalized. It goes into the hardware, you put the sample on the hardware. The hardware is told to do, because you programmed the app using the QR code that you generated in Julie. The app runs the meter gives the data back to the app, and the app sends the data to Julie, where in fact the signal extraction and the calibration routine that you developed then turns that into a concentration, and the person will get the result on their phone. So you really have now given them a user experience. And when you watch videos from ZP, you're going to find out that we're not showing voltammetry on our Sense It All platform. That might be what's happening in the background, but you're certainly not showing that to the end user. And so it gives them a really nice experience. So what this stack of technologies is doing is then saying, stay what you're doing. If you develop electrochemical assays or electrochemical sensors or electrochemical biosensors, stay what you're doing. Just move on to some of the screen printed electrodes from ZP. Hopefully choose the carbon ones, because commercially these are going to be the easiest one for you. Use the EMMA potentiostat from ZP, because that then integrates with Julie. So you can do nice parallel work in the lab, which is efficient on your time. The method files then go to Julie. When you're in Julie and you're analyzing your data using the data science tools that we have there, you'll end up with a signal extraction routine and you'll end up with a calibration routine. Those 3 files, the method, the signal extraction, and the calibration routine, can then be condensed down to a QR code. And then there's a Sense It All platform which will read that QR code, take on board all the stuff that you've essentially developed, and then it's essentially good to go. The Sense It All app will tell the meter what to do. You'll tell the user, put the sensor into the meter, put the sample on the meter, run the app. The app will run the method file. The meter will give the data back to the app. The app loads it to Julie. Julie will put it through the signal extraction routine and the algorithm routine, and then give the app back the number. And you actually get the raw data as well. So it really helps you kind of keep an eye on what's actually going on. Now, I also said there's an API on this as well. So Julie, the word Julie, this cloud database that we have at ZP, it is proprietary, something that we developed ourselves. It does have an API, an application program interface. API, I know I've said it already, but all banking, all online commerce, all booking of tickets, probably even sort of government subsidies. Everything is stuck together these days through API. So we do have an API built into Julie. And this is really useful because it actually facilitates innovation. So if you're working with other parties, they can bring data from that your sensor may have otherwise developed into their cloud system, and you can charge them on the API, which allows for monetization. It also gives you an ecosystem for growth. So other people may be able to use your hardware and sensor technology in their application, and therefore you can then plug into their ecosystem. This can give you a cost reduction in terms of actually if other people are out there using your technology and putting it into their business models, that really saves you on sales and marketing. It improves customer experience. So for example, if you develop a sensor and you're sort of serving up the data in your own language, then people in other countries can essentially get hold of the data. They can put it into a way that is acceptable to the local market and essentially improve that kind of customer experience. It allows for data access and analysis, so other people can bring your data in and do essentially data fusion, bring your data and mix it with their data and add value to it. This really allows you to have a kind of global expansion that things that or markets that you would otherwise find it quite hard to address. Other people, if they can build their business upon your technology, then eventually you all benefit from it. This is definitely a competitive advantage. Building an API in from the very start with your business ideas is a competitive advantage. This is the way modern business runs, and it also allows you to kind of have this rapid development as well. And also, importantly, it also gives you scalability. So if you make your platform more available for others to use in their technologies, then you have a much more scalable product, and that really comes into interoperability. API is really important for interoperability. You want to be able to plug into the modern world, so you should have an API. So I started this conversation by saying ZP is, if your idea is to use electrochemical analysis along with screen printed electrodes, then the ZP technology stack will take you from SPE, screen printed electrode, to MVP, minimally viable product, to API, and this is that API part. Now the SPE is our screen printed electrodes. They're available. Hypervalue carbon electrode, I can't recommend it more. Simply, we use it all the time, and it's highly reproducible. Highly reproducibility from us gives you great repeatability in the lab. The next part you then need is to actually get enough data to make your assay robust enough. How do you do that? Use the EMA potentiostat. A, it's got 6 channels on it, and B, actually the method files then will feed into Julie, and then Julie will start turning your lab work, essentially condense it into a QR code, which will then be read by the Sense It All app and will allow you to then use the Sense It All platform as a friendly customer-facing solution and not giving people a sort of horrible, clunky potentiostat experience. And so the revolution is we can quickly turn ideas into tangible products. I would always recommend these carbon electrodes. We're essentially, I would say, eliminating the chasm between ideas and commercialization. A lot of what I've spoken about is actually just doing what you're already doing, but actually just doing it on a platform that's intended to get you from idea in lab to actually product on the market. And if you sort of essentially come into this, then we'll actually be able to get you onto the Sense It All platform, and I think then you're on your way to commercialization, and it's already got an API built into it, so you've already got scalability and interoperability plugged into it. So I want to say thank you for this. As you can see, if you've got any questions, don't hesitate to reach out to us at ZP. and I'll try and put some useful links underneath the video as well. Okay, thanks very much. Bye bye.